Okay, on this lesson we're going to be talking about roots and factors. So the root-factor relationship, so we've been factoring. So we were given something that looks similar to this. So this is a polynomial equation. Notice we have a f of x, which is your y. And we're going to be finding the zeros, roots, solutions, x-intercepts, and factors of the function. It's related to this equation. Notice the f of x is y and it's equal to 0 there. So it says for polynomial functions f of x equals x cubed plus x squared minus 2x. The blank of a function are located at the points. So these points, notice the y values are 0. Anytime I have a y value of 0, that's called an x-intercept. And then the blank are the coordinate points where the graph intersects the x-axis. So those are x-intercepts. Okay, so then it says the blank of a function, there's your equation, are located at -2, 0, and 1. Notice those are just the x values of what we were just looking at the top. So if you look here, it's just the x values. Those are called zeros, which is where it crosses the x-axis again. So it says the blank are the x values of the x-intercepts, or the x values where f of x equals 0, which means y equals 0. So that's zeros. Okay, the next part, the blank of a function are x, x plus 2, x minus 1. Notice that those are similar to these up here, but the opposite there. So these are called your linear factors. So remember when we were factoring, we would get something that looks like that. And then notice it's just the opposite. So x plus 0, and then that's the opposite there. Okay? It says now notice how the sign in the factor is the opposite of your zeros, solutions, roots, and x-intercepts. Next piece, the blank of an equation, so that's equal to 0, or -2, 0, and 1. Those are called solutions. And then the blank are the x values where f of x equals 0, which means y equals 0. So the x values are also called solutions. So notice all of this is very similar. Zeros, solutions, they mean the same thing. Okay, notice the next part is also very similar. And this is roots. So roots, solutions, and zeros mean the same exact thing. X-intercepts go with it too, except it's written as an ordered pair for an x-intercept. And then a root of a polynomial equation is another name for the solution of the equation. All right, so this next part, it says the factor theorem states that the polynomial has a factor of x minus a. Remember, that looks familiar when we were using synthetic division. That was the denominator. And then it says f of a equals 0. So that means when you plug it in, you get y value of 0. Notice that it says f of x equals x times x plus 2 times x minus 1 is the factored form of your function shown on the graph, because f of 0 is 0, f of -2 is 0, and f of 2 is 0. So that means when x is 0, notice your y is 0. When x is -2, your y is 0. And when x is, should be +2, it's 0. Okay, let's look at our first example. It says we're going to factor the polynomial function, and then we're going to complete the chart by stating the linear factors, zeros, roots, and x-intercepts. Finally, you can use a graphing calculator to sketch the graph of the function. So first thing I have to do is I have to factor it. So notice first thing is GCF, but they don't have anything. So remember, whenever you're factoring 3 terms, you're using sum and product. So the sum would be -5, product would be 4. So that would be, notice your first term is x to the fourth, so that would be x squared. And it would be minus 4 and x squared minus 1. You multiply negative 4 times a negative 1 and you add and you get negative 5. Now, remember whenever you factor x to the fourth, sometimes you can continue on with your x squareds. Notice both of these are difference of two perfect squares, so we can continue on. This one would factor to x plus 2, x minus 2, and then this one would factor to x plus 1, x minus 1. So there's our factors. And then we're going to find the zeros. The zeros are actually the opposite of this, because remember, if we look back up, where is it? Right here. It says x minus a, so it's the opposite. So that 0 would be negative 2. This 0 would be positive 2. This 0 would be negative 1, and then this one would be positive 1. So those are our zeros. And then remember zeros and roots. If you look back up at the top, zeros and roots, those are the same exact thing. So it doesn't really matter which order you list them in. And then our x-intercepts, they are the same thing, except it's an ordered pair. So negative 2, 0, 2, 0, negative 1, 0, and 1, 0. So it's just the way that you write it, but they're including the same x values as your zeros and roots. All right, so I'm going to go ahead and graph those because I know those are my x-intercepts. So I'm going to plot them, negative 2, negative 1, and then 1, 2. And then we can plug it into the calculator. So I would suggest plugging this in, your original. You can go to y equals, plug it in. And since we already know the x-intercept, really all we care about is the direction of your polynomial equation. And then also where it crosses the y. So when you go to y equals and you type that in, when you press graph, you need to go find where it's crossing the y. So it crosses it at 4. So, and it looks similar to this. So when you press graph, that's what it should look like. So we already know what the roots are, which are your x-intercepts. All right, let's look at the back. So we're using the graph to determine the zeros, roots, x-intercepts, and linear factors. So we're just finding the roots, which are your zeros, your x-intercepts. So let's find those. It's crossing the x at negative 1, it crosses the x at 2, and 3. Okay, so remember zeros, roots, they are the same thing. So that's negative 1, 2, 3. Remember x-intercepts are the same thing, but remember that you are putting it as an ordered pair. So that would be negative 1, 0, 2, 0, and 3, 0. Remember your factors are in the form x minus a. So this would be x minus a negative 1, which would make it x plus 1. This one would be x minus a, which is 2. And this one would be x minus 3. So remember, going from x-intercept or roots, zeros to factors, it's the opposite. So don't forget to do that. All right, let's look at number 3. So this time we're given a table, and we are going to use the table to determine the zeros, roots, x-intercepts, and linear factors. So I'm going to start out with, I'll just label it as zeros, roots, x-intercepts, and factors. All right, zeros. So remember, zeros are your x-intercept. So we know anytime we have an x-intercept, our y is 0. So that's what you really need to focus on, is when y is 0. Here's our y values right here. Oh, let's go back. All right, so our zeros would be negative 3, 0, and 5. Roots are the same exact thing. X-intercepts are not the same thing. They are the same thing, but they look different. We're just writing it as an ordered pair. And then our factors, remember, are in the form x minus a. So that would be x minus a negative 3, which will make it plus 3. X minus 0, which is just an x. And then x minus 5. And if you want, you could also just put it as x plus 3, x minus 5. Now, if we had factored it, we would have got this for our answer. So this is another way of finding our factors, looking at a table, looking at a graph, and then finding our zeros and changing them to factors. Okay, number 4, we're going to factor the polynomial and then determine its linear factors and roots. So first thing I look for is the greatest common factor. Notice that all 4 of them don't have anything in common. So I'm going to go straight into grouping because there's 4 terms. GCF is x squared of those 2, which would be x plus 5. Bring down your middle sign. GCF of those 2 would be 16. And that would leave me with x, that would be plus 5. So remember, we group. We're writing this once, and then we're grouping together the x squared minus 16. Remember, when there's a squared, you always need to check for difference of squares. Notice we can factor this again to x plus 4, x minus 4. Bringing down my x plus 5. Okay, so we're going to write it in factored form. So I'll label this as factor form. So writing your actual function here. So f of x equals, it's the same thing, x plus 5, x plus 4, and x minus 4. Then we wanted to find just the factors, so I'll just put factors, which are those 3 things we just found. And then it wanted the roots. Remember, roots are your x-intercepts, your zeros. So roots are the opposite, so that'd be negative 5, negative 4, and positive 4. So the tricky part is when you have factors, your roots are the opposite of that number because it's in the form x minus a. All right, last part. So use the given information to translate between zeros, roots, x-intercepts, and linear factors. So we're given the roots here. We want to find the factors. Remember, factors are in the form x minus a. So x minus 3, x minus a negative 5, which makes it plus 5, and x minus 0, which would just be an x. So we can just put x instead of parentheses. Okay, so part B. We're given the factors this time. We want to find the x-intercepts. So x-intercepts, don't forget, we want the x value and the y, which is 0. So it's the opposite of your factors. That would be 4, 0, negative 3, 0, and 2, 0. Part C, we're given the x-intercepts. We want to find the roots. It's just the x value. So we have, I'll just put it least to greatest, negative 3, negative 1, 0, 7. And the last one, we're given the zeros. We want to find the roots. Remember, zeros and roots mean the same thing, where it crosses the x-axis, so just those numbers. Okay, so this is a polynomial. We've been talking about polynomials. Now this is a way that you can graph it, and also another way of finding your factors without actually factoring the polynomial.